Hey guys, welcome to the first part of my beginner MultiRotors series. Right now I'm going to be talking about configurations as in Tricopter, Hexacopter, Octocopter, Quadcopter, and so on. Since I'm basically aiming this towards beginners, people looking to get into this, we're going to do basically the most popular setups out there, and I'm going to go over the pros and cons of all of them. So what we're going to start with is the Tricopter. The Tricopter is generally the lowest part count just due to the amount of motors and speed controls and props and so on. So one of its pros is low investment. It makes a good platform for cameras due to the front arms being angled out. You can generally get a pretty clear viewing angle. So minimal parts, minimal setup. There's a potential for folding if you buy, like say, the Talon Tricopter frame that has folding potential. So it'll pack up nice and small. Now the cons, and there are a few pretty good sized cons with Tricopters, is the only way that you can get a yaw effect when you have an uneven number of motors is with a servo mounted to the tail. Now when you mount a servo to the motor itself, it gives you your yaw control, but it adds a whole element of complexity as far as making sure that that angle rotates properly, that the motor's rotating properly, and you have a strong enough servo on there. So you have more complexity in there, but you also have some less stability just due to the nature of three motors. You have less points of rotation, so it's not quite as stable as, say, a quad, a hex, or an octa. And you generally need a little bit bigger motors because you're lifting with three motors instead of 4, 6, or 8. Another thing you have in a Tricopter that isn't so great is there's no redundancy at all. That's also true of a quad, but with no redundancy, if anything fails, I mean literally anything, if your servo in the tail fails, if your motor fails, if your speed control fails, you're going to be losing the craft. It's going to go down. So let's step into the quadcopters. Typical configurations for quadcopters is going to be a 4 motor in an X configuration or a plus configuration. They fly basically exactly the same, it's just how they're programmed. Now pros, it's simple, it's elegant, it's generally fairly powerful because you have 4 motors instead of 3. And they're pretty forgiving as far as setup goes because you have no servo motion, you don't have anything to play with in your flight control board. So pretty forgiving. It's probably the best setup to start with. Now the downsides, there's no redundancy, same as a Tricopter, so if you lose a motor or a prop, you're generally going down. If you're low, you can sort of bury the sticks and sometimes keep it afloat, but it's not going to come to a nice landing. You're still probably going to crash. And it's not as stable as, say, a Hex or an Octocopter just because it only has 4 points of rotation rather than a Tricopter, which is 3, or a Hexacopter, which is 6. Now we're going to jump into the Hexacopter. These are also available in plus or X configuration. Pros: lifting capabilities. Hexacopters can generally lift quite a bit because you've got 6 motors, so you don't have to put quite as burly a motor on there depending on the weight you're intending to lift or the batteries or the frame. But you can go with some slightly lighter weight motors generally. There is minimal redundancy. I've actually completely lost props on Hexacopters and still managed to fly back no problem. Depending on how well your flight control board is set up, it should be able to do with a prop breaking or a motor stopping. Inherent stability, 6 points of rotation. So there's an inherent stability with Hexes. Now the cons is cost. Obviously you're spending twice as much money as you would a Tricopter or close to it because you're needing to buy 6 motors, 6 speed controls, and so on. They do tend to be bigger and they're slightly less agile. Now there's a few ways you can kind of argue the maneuverability aspect of more motors. They can be just as maneuverable as quads or tris, but for the most part when you set up a Hex or an Octa, it's best off to keep them sort of more in the stability rather than the maneuverability range. Now those slightly less common ones will be the Octocopter. That's going to be an 8 motor setup. They're really good for heavy lifting, very stable, and high redundancy. You can almost always lose a prop or a speed control. If things are set up properly, you should be able to recover it no problem. Cons: expensive, very expensive. I mean, you're talking twice the amount of components as a quad. And also another way of looking at the larger setups is it's more surface area. It's more rotating surface area, especially. If you have 8 or 6 props, that's a lot more area for the wind to hit and affect you. So even though you have those points of rotation, you're giving it a lot more to hit. So there's a couple ways of looking at it. Let's do one more quick one. It's going to be a little bit of a weird one, and it'll tie into sort of two. There's Y6s and then there's X8s. A Y6 is shaped like a tricopter, or a Y, and it's 6 motors, which means you have coaxial motors on each boom. You have a motor on top, motor on bottom, spinning opposite directions. So you end up having 6 motors at 3 points of rotation. Good redundancy. You can definitely lose a motor and keep those things afloat. And good lifting capabilities. Now the downside is coaxials generally reduce the efficiency and they stress the props a little bit, so you have to have really good props and you have to have a slightly bigger battery because you're sort of draining a little bit more energy. And less points of rotation again. You've got the 6 motors, but you only have 3 points of rotation, which means you're still very sensitive to certain motions. X8s are sort of another example. I've built X8s before. They're very interesting, but it's basically a quad with 8 motors. You've got them top and bottom. I've had props disintegrate on X8s and barely could tell the difference. That's really nice. You get more rotational points, but again, you're increasing cost, you're increasing complexity, and the more components you put on, the higher the probability of a component failing is. But there's a sweet spot. I think the sweet spot generally tends to be the hex, and for beginners, the quads. But I hope this information goes out to the right people and you find it useful, and it's sort of helping you out, getting your mind around what this multi-rotor thing is. So if this did help you out, please thumbs up, subscribe, and I want this to be a community. I want people talking in the comments. So if you have any questions, feel free to comment. I will do my best to answer, and if anyone else has the answer, feel free to comment right back. Thanks for watching, guys. Talk to you next time.